For this example, we have a situation where we are dealing with an R ohm resistor. So we've got three resistors, R sub 1, R sub 2, and R sub 3. They're all connected in parallel and they create this R ohm resistor. So the value of the total resistance can be found by this equation. 1 over R equals 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3. We want to find the partial of R with respect to R sub 2. So don't get that confused with a higher order derivative. That's a subscript or an index value. So we want to find that partial when we know the values of R sub 1, R sub 2, and R sub 3. And of course, these values, resistance is measured in ohms. So we're going to differentiate this with respect to the independent variable R sub 2. R is going to be my dependent variable, and R1 and R3, those are going to be constant values. So we're going to differentiate with respect to R sub 2. I'm going to rewrite R as R to the negative 1 equals R sub 1 to the negative 1 plus R sub 2 to the negative 1 plus R sub 3 to the negative 1. And the only reason I do that is it makes it easier for me to differentiate. So differentiating my dependent variable, R, that's going to be negative 1 R to the negative 2, or rather just negative R to the negative 2. Now I differentiated R, so I'm going to write dr sub 2, or partial R sub 2. The derivative of this, R sub 1 is a constant, so that's going to be 0. Differentiating this guy, I'm going to have negative R sub 2 to the negative 2 power, and then that third term, R sub 3, because that's a constant, that would be 0 as well. So, cleaning this up just a little, I've got negative 1 over R squared, partial R sub 2 equals negative 1 over R sub 2 squared. So finding the derivative, I want to isolate, so I'll multiply by the reciprocal, dr partial R sub 2 is negative 1 over R sub 2 squared times negative R squared, and those negatives will turn to a positive. This R squared just slides right into that numerator, and there we have this value here. So this represents the change in the resistance when we apply a small change to R sub 2, the overall resistance, versus that one resistor in parallel. So we want to find this value when we know these ohm values. So I know what R sub 2 is. R sub 2 is 45. I'm going to be able to plug 45 in there and square it, but I don't know what R is. Fortunately, we can go back to our original equation and I can plug all of these values in to find R. All right, so I'm going to write this down here. The original equation was 1 over R equals 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3. Or rather, 1 over R equals 1 over R sub 1 was 30, R sub 2 was 45, and R sub 3 was 90. If we solve this basic equation, we're going to get that R equals 15. So we can come over here with this guy and say the partial of R with respect to the independent variable R sub 2 is going to be 15 squared over 45 squared, which that will simplify to 1/9. So what this means is at the given ohms, a small change, if I make a change to R sub 2, a small change in that resistance will lead to a 1/9 proportional change in the overall resistance. All right, so that's a situation where we can apply partial derivatives. As always, feel free to email me if you have any questions.